Hi guys, I'm back with another video. This is the proof that the angle at the center is twice the angle at the circumference. So in the previous video we investigated what happens if we take a chord and we subtend an angle at the circumference and use the same chord and create an angle at the center. And we found out that the relationship between these two angles is that the angle at the center, which is D, it will be twice. If you look at it, this is angle ACB times 2, which is equal to the angle at the center. So meaning that the angle at the center is twice the angle at the circumference. So how do we prove that algebraically? So let me just use a red color here. So I want to construct an exterior angle, but what I'm gonna do, I'm going to um, join CD and produce to E. So what did I do there? I've just construction. So I've just done a construction and I've joined CD and produced it to E. So now what happens? I've just created two triangles here. I have triangle 1 and triangle 2. So in triangle 1, which is CAD, this is the triangle CAD, and I've created two angles here. I've created D1 and D2. So in the triangle CAD, I have the exterior angle D1, which is equal to, let me just also label C1 and C2, and then, yeah, which is equal to C1 plus A, and that is the exterior angle of a triangle is equal to the sum of the interior opposite. So now if I have an exterior angle here, it is equal to this angle here plus this angle here. So the exterior angle of a triangle is equal to the sum of the interior opposite. Fine. And also because AC or CD is equal to AD, so there we have CD is equal to AD, and that's because both of them are radii. So CD is equal AD and both of them are radii. Both of them are radii. It means that C1 and A are equal. So C1 is equal to A because their angles opposite equal sides. So meaning that D1 is equal to 2C1. Very simple, right? Then we continue. Let me use a different color. I'm gonna use blue now. Okay. In the triangle CBD now. In a triangle CBD, we have that D2, the exterior angle, is equal to C2 plus B. Why? The exterior angle, that's the exterior angle of a triangle, is equal to the sum of the interior opposite. So now we know that C2 and B are equal. We know that D2 is equal to C2 plus B. Another thing is that DB is a radii, and then DC is a radii, meaning that these two are also equal, right? Because the three lines are lines from the center to the circumference. Center, circumference, center, circumference. So still CD is equal to DB, and the reason is because they are radii. The reason is radii. Fine. That would mean that B is equal to C2. So C2 is equal to B, and it's because angles opposite equal sides. So now it means that D2 is equal to 2 times C2, this angle D2. And if you look at the angle at the center now, the entire angle at the center, this angle here, it is comprised of D1 plus D2. But we've discovered that D1 is equal to twice of C1, which is the angle at the circumference, one of the angles at the circumference, plus twice this other angle at the circumference, which is C2. And if you factorize now, it's going to be 2 times C1 plus C2. So meaning that the angle at the center, if you look at the angle at the circumference, it's made of C1 plus C2, and then the angle at the circumference, it is comprised of, let me just fix that one here, it's C1 plus C2. So angle at the center is made of D1 plus D2, right? And which is equal to 2 times the angles at the circumference, which is C1 plus C2. So hence we've proved that the angle at the center is twice the angle at the circumference. So in another video, I'll be exploring the next variation of the angle at the center is twice the angle at the circumference. Do like, comment, and subscribe.